Hello guys, my name is Sanjeev Reddy and welcome back to Statistical Academy. I am a senior statistical programmer and in this channel I make videos on programming, career guidance, clinical research, drug development, regulatory guidance, LinkedIn profile building, interview guidance, resume building, R programming, Excel and many more. In this video, we are going to be talking about the usage of data step to create a SAS dataset. We will be covering reading and filtering the data, computing new variables and conditional processing. So let's get started. Don't forget to hit the subscribe button and leave a comment with your thoughts on the topic. Let's learn together. The links for the program and the example datasets I use in this video are in the description below. I would like you to practice as much as possible with your own examples as well. So now you are able to access and explore the data. We will manipulate and prepare the data now, using the data step to create a SAS dataset. When you work with the data, you want to preserve your existing data and create a new version of it. In simplest form, the data step does just that. Data step reads an existing dataset and writes a new one. The data statement names the output dataset or the dataset you wanted to create. If you use the work library, it will be a temporary dataset. If you use any other libraries, it will be a permanent dataset. The set statement names the input dataset or the existing dataset that you are reading. The run statement ends the step. Note that if the output dataset you list in the data statement already exists and if you have write access to it, the data step overrides the dataset and there is no undo. In this example, the data step creates a new dataset, new class, in the work library by reading the class dataset in the SAS help library. The output dataset new class is an exact copy of class. We wouldn't write a program just to make a copy of data. This is only the beginning of the data step. Now we will see a demo. You have seen how can you make a copy of data, but who needs a copy of data as it is? The whole point is to make a dataset that has just the information you need or you want. So let's look at how can you use additional statements in a data step. Let's start by filtering or subsetting data. The same where statement that works in a procedure to subset data for a report or analysis works in the data step as well to filter the observations. Only those observations from the input dataset that meet the criteria in the where statement are processed by the data step and returned to the output dataset. So I will add a where statement where age is greater than or equal to 15 and I will run the step. Results look great. Now in this dataset of a new class, we only have students where age is greater than or equal to 15. Alright, back to the program. You can also limit the variables in your output data. To do this, you use either the drop statement or the keep statement, followed by a variable names from the input dataset you want to drop or keep. It doesn't matter which statement you use. So choose the one that lets you specify fewer variables. So in this example, I could use a keep statement and list name, age, height, followed by a semicolon. I will run that program and notice that only those three variables are included. Or as an alternative, I could drop the variables I wanted to eliminate. So drop and then sex weight. This would also produce the same result, leaving the only remaining name, age and height variables. You might also want to change how the data values appear in the data. So let's go back to the program and I will delete my drop and keep statements. What if I wanted to change how the data values appear in the data? We have used the format statement in procedures to change the how data values are displayed in a report or analysis. We can use that same format statement in the data step, but the impact is little bit different. A format statement in the data step permanently assigns a format to a variable in the properties of the new dataset. The raw data values are still stored in the dataset, but anytime you view the data or use in procedures, the formats are automatically applied. So in our data, I would like to use a format statement and I will display height with 4.1 format, meaning we will round those values to the nearest tenth. And weight I will format as 3 dot, so those numbers will be rounded to the nearest whole number. I will run this code and take a look at the display values for height and weight. I also wanted to point out over in the variables tab, if I select height by clicking on it, height variable, we can see the properties down below and notice that format 4.1 has been permanently applied to the variable, and weight, it has 3 dot format applied. So this is just the very beginning of what we can do to manipulate data in the data step. We already have seen some examples in the initial videos. In your real time, your data does not have all the variables that you need. You need to calculate or derive new variables from existing variables. Fortunately, this is easy to do with the data step. To create new variables, you use an assignment statement. You simply type the name of new variable, an equal sign, and then an expression that creates the new data value. In this example, the where statement includes observations where origin is not equal to USA. Remember that SAS is reading the data from cars dataset one observations at a time. The first assignment statement creates the numeric variable profit and generates a value for every observations in the output dataset by subtracting the value of invoice from the value of MSRP. The second assignment statement creates a variable named source and assigns the character string non-US cars. Without a keep statement, the output dataset would include all variables. But because there is a keep statement, you must list new variables and whatever the variables that you want to include, so that they are included in the new cars dataset. Now we will see a demo. We have the dataset named subjects and I wanted to create a new dataset from this dataset. The new dataset name is new subjects. In the new subjects dataset, I only want female subjects. We wanted to create two new variables called height in centimeters, weight in kgs. So we have to use the existing height and weight variables to create height centimeters and weight kgs. Also in the new subjects dataset, I only wanted to keep ID, height cm, weight kg and gender variables. Okay, we have now understood the new dataset requirements. Let us write the program to achieve this. In this example, we are creating the dataset new subjects and the input dataset is in the practice library. So set practice.subjects. And we only want female subjects, so where gender equal to female in quotes. And what if I'd like to create new variables? Height in centimeters, which converts height in inches values to the height in centimeters. And weight in kgs variable, which converts weight in pounds to weight in kgs. So I'm going to use the assignment statements to create these new variables named height underscore cm, follow that with an equal sign and then provide the expression which will just be height multiplied by 2.54 and weight underscore kg equal to weight multiplied by 0.4536. And I would like to have only ID, height underscore cm, weight underscore kg and gender. So I will use keep statement to limit the variables in the output dataset. Of course, I could also use drop statement to remove whatever the variables I don't want. I'll run this program. Now we have derived height in centimeters and weight in kgs. Also, we only have female subjects in this dataset. Remember, it is always good idea to look at your log to verify that everything ran successfully. See if there are any interesting notes that you need to be aware of. Arithmetic calculations and character constants are a good start for creating new variables, but often you need more elaborate or flexible methods for generating the new data values. SAS offers hundreds of functions that can be used in countless ways to manipulate numeric, character, and date values. A function is defined routine that returns a value. The syntax for a function is the function name followed by the arguments enclosed in parentheses. The arguments consist of the input that the function needs to be perform its specific routine and return a value. If there is more than one argument, they are separated by commas. Functions can be used in assignment statements to generate a value for the variable. Now let us explore some numeric functions. We have a dataset named marks with 100 records of students and their marks in English, physics, maths, chemistry and biology. Now I wanted to create a variable named total. Next I wanted to create average, median, minimum, maximum, non-missing and missing variables. So we will go to the SAS Studio and write the program. I will be creating a new dataset named marks_new. I am now taking the dataset marks which is in my practice library. We will write the sum function for total. Sum function returns the sum of all non-missing values. Sum in parenthesis, we will have to write the numeric variables separated by comma. We want to sum the marks of English, physics, maths, chemistry and biology and end the statement with a semicolon. Main function returns the average of all non-missing values. Median function returns the middle value of all non-missing values. Minimum function returns the minimum value of all non-missing values. Max function returns the maximum value. N function returns the number of non-missing values. Nmiss returns the number of missing values. Let us run this program. The new variables are added to the end of the dataset and there we see total. By using sum function we have derived the total of these variables for each student. Same way we have derived average using mean function, middle value by median function. When we use min function, we will get the minimum value. For example, in this first observation, 55 is the minimum value. So it picked the value of 55. And maximum value using the max function. We have used n function to create the variable total_subjects, which is the number of total non-missing values. So here non-missing values are English, physics, maths, chemistry and biology. So total 5 arguments we have given in the function n. It returns the value 5 because of no missing values. The function nmiss returns 0 here, but if you can see the second observations, there is a missing value. Because of this, total subjects are 4 and the absence is 1. Now let us look at some character functions. First, let us look at the data. We have the adverse events data set which has 600 observations. As you can see, adverse event term has case inconsistencies. I want all of them to be in proper case, which means first letter should be in uppercase and rest all in lowercase. Next, I want the AE severity variable to be in uppercase. All of the values should be in uppercase. Study sites are spread across 3 variables, but I want all of them to be concatenated to one variable. And then from this death flag variable, I wanted to extract the last letter. N stands for no, Y stands for yes. So in my death flag, I wanted to populate only Y or N. For that, I need to extract the last letter from this variable. So that's our goal. I will close this data set and come back to our SAS Studio. For my data step, I'm creating a new temporary dataset named adv_events and reading the existing practice.adverse_events dataset. Let's go ahead and add the assignment statements. So the first thing I wanted to do is convert the AE term to proper case. To do that, I'll build an assignment statement. AE term equal to prop case in parenthesis AE term semicolon. So notice in this statement, I'm using the same variable as both input to the function as well as the variable name that we are writing to. So we will override the AE term with the proper case value. And next I'll do similar for the AE severity, but instead with the uppercase. Next I will create the study underscore site variable to concatenate the study underscore site 1, 2 and 3 variables together. I will use the cates function and the arguments will be study underscore site 1, 2 and 3 variables. Remember that cates function will remove any leading or trailing blanks around the values of those arguments before concatenating them together. And finally, I will add an assignment statement to create death flag, and for death flag I will use the substring function, and the first argument will be the variable I wanted to extract the value from, so that's death flag. The second argument is the start position that I wanted to read, so that will be the position number 3. And the third argument is how many characters I wanted to extract. I just want that last character, and that's the conclusion of my data step. So let's run the program. And notice that AE term is now in proper case. AE severity is in uppercase. Study site now has the concatenated value, and death flag has only the last character, that is N or Y. It looks great. There are so many things you can do with the character functions to manipulate your data. We will now see the usage of date functions. Before going to SAS Studio to write program, we will look at the data. We have an exposure data set which has treatment information with start date and end date, which are in raw numeric SAS date form. So each of these numbers represent the number of days from January 1st, 1960. First thing I wanted to calculate is duration in days between start date and end date. The variable name is duration underscore days, which is the duration of treatment in number of days. I wanted to create 3 other variables. Those are month, day, year from the start date. Also, I wanted to create one more variable, today's date. Finally, I wanted to create years passed from the start date of treatment to till date. So let us go back to SAS Studio and look at the program. First, we will calculate duration in days between the first treatment date to end date. Duration underscore days equal to, and then intck function. The intck function in SAS is used to calculate the number of intervals between 2 dates or datetime values. It takes 3 arguments, an interval, from date and to date, that is start date and end date in our dataset. The function calculates the number of intervals of the specified type between the 2 dates or datetime values and returns the result as an integer. We will have to mention the interval in single or double quotes and then comma, starting date and end date. In our case, it is day, but you can also handle other types of intervals like week, year, quarter, hour, minute, second and so on. Next, we wanted to extract only month from the start date variable. The function is month and the argument is our start date variable, which will extract only month from the date. The same way, day function will extract only day from the date. and year function will extract the year from the date. I want the today variable to be today's date, whatever the current date is when the program runs. So I'll use the today function to get that. Remember, the today function doesn't need any input in the arguments. Just open close parentheses are sufficient. Years passed. To calculate this value, I'll use the yearDiff function. And the first argument is the starting date. So this will be the start date variable in our case. The second argument is going to be the end date. I want this to be dynamic. I will use the today variable which was derived just before this step. The last argument is the basis or the method for performing the calculation. The basis will just be age in quotes. To keep track of the parentheses, you'll notice that as you click on one parenthesis, it highlights the corresponding parenthesis on the other side. So you can ensure that every parenthesis has a match. Finally, I wanted to apply ddmmyy10 format to start date, end date and today variables. 4.1 format for years from the start variable. I will use format statement to achieve this. I will run this program and you can see formats ddmmyy10 applied to start date, end date and today's variables. Also, we can see the duration in days between start date of treatment and end date of treatment. Also, we can see day, month, year from the start date. Looks great. This is just the beginning with functions. We will learn many numeric, character, date and time functions throughout our course. Often in the data step, we need to process data conditionally. In other words, if some condition is met, then execute one statement. If a different condition is met, then execute another statement. We can accomplish this using if-then logic. For example, if the phone battery is low, then you keep it for charging. Let's look at this example code that's reading the sashelp.cars dataset. In the new cars dataset, we wanted to create a new variable named cost group and assign a number to the variable based on the value of MSRP, which represents the manufacturer's suggested retail price. We need to use conditional logic to do this. After the keyword if, we provide a condition MSRP less than 30,000. If the condition is true, then execute a single data step statement. Assign the value 1 to the new variable cost group. A second if-then statement evaluates the condition MSRP greater than or equal to 30,000, and if the condition is true, then assign the value 2 to the variable cost group. Each if-then statement ends with a semicolon. dm dataset and sdtm_dm includes the age variable. I would like to create a new variable named age group. Let us say age group will have a value of either 1 or 2. If age is less than or equal to 40, age group will be 1. If it's greater than 40, age group will be 2. So I can handle that logic with if-then statements. So I'll start by adding if age less than or equal to 40, then age group equals 1. And I'll add another if statement. If age greater than 40, then age group equals 2. So I'll run this code. Let's see what we get. Notice when age is greater than 40, we are getting age group equal to 2. Otherwise, age group seems to be 1, including those observations where age is missing. So remember, a missing value is treated as the smallest possible value. So going back to the code, if age is missing, then the first condition is true and age group is 1. Well, what if I add another if condition, something to account for the missing value of age? So if age equals numeric missing a dot, then age group equals missing. So we'll use the numeric missing value of a dot to assign to the variable age group. So let's see what happens with this data step. Notice when age is missing, it's still being assigned a value of age group equal 1. Well, why is that? Let me go back to the code. The problem is when age is missing, the first condition is true. Therefore, age group is assigned a value of missing. However, the second condition is also true. So the value of age group is overwritten with the 1. That is what output to the new data set. So the last assignment statement determines the value of age group when age is missing. We'll need to handle this in a different way. When you have multiple if-then statements, SAS tests all the conditions in sequence for every observation of the data. The statement that executes on the last true condition determines the values in the output dataset. Suppose you want to treat these conditions as a hierarchy so that when a true condition is found, SAS executes the statement following then and skips the subsequent if statements. If you wanted to enforce this type of testing, then the keyword you add is else. In this code example, you can see that else is not in the first statement, but it has been added in the 3 statements that follow. This tells SAS to test the condition only until a true expression is found. MSRP is equal to 35,000. The first if-then statement is false, so SAS moves on to the next statement. The second condition is true, so SAS assigns the value 2 to the cost group and skips the rest of the conditional processing statements. For an observation with MSRP equal to 75,000, none of the stated conditions are true, so this last statement is executed. Notice in this final else statement, there is no condition, just an assignment statement. There is no reason to test the final condition because if the preceding conditions were all false, we know cost group is 4. You might be wondering whether you can evaluate compound conditions, and the answer is yes. You can create compound conditions with AND or OR. If you use AND, both conditions must be true. If you use OR, one condition must be true. You can also use conditional processing to create character variables. Remember that the variables in an output dataset are defined in the compilation phase of the data step. When SAS reads through the code, the first occurrence of a variable defines the name, type, and length of a variable. SAS is not processing the conditional logic when it compiles the code. It just sees the assignment statement, and as programmed, the first assignment statement defines a character variable and assigns the value basic. So SAS creates a variable named car type with the length of 5, the number of characters in the word basic. You can see in the output dataset, the word luxury is truncated because it has 6 characters. One way to avoid this problem is to explicitly define a character variable in the data step with a length statement. The syntax for this statement is the keyword length followed by the name of the variable, a $sign to indicate a character variable, and the length you want to assign. In this example code, the length statement defines the car type variable with a length of 6 before the conditional processing statements. If you can specify a compound condition to evaluate, can you do the same after the keyword then to execute multiple statements? No. If you try and use N between 2 statements, the program fails with a syntax error because you can only have one executable statement following then statement. Don't worry, SAS has another way to execute multiple statements for a given condition. We call this syntax if then do. After condition, you type then do and a semicolon. After that statement, you can list as many statements as you need to process. At the end, you close the block of statements with an end statement. This is repeated for each of the else if blocks. For the last statement, you use else do since you are not evaluating an expression in the last statement. Suppose we wanted to conditionally write output to two different data sets. In the data statement, we can list more than one output data set. So in this example, we create two data sets, below 40 and above 40. In the first condition, if MSRP is less than 20,000, we assign cost group a value of 1. Then we use the explicit output statement to tell SAS which of the two datasets to write that observation to. Just remember that because these statements execute in sequence, the output statement must come last in the do group. The remaining conditions include statements to assign a different value to cost group and output to either the below 40 or above 40 datasets. In this program, we will use if then do syntax to execute multiple statements for each condition. So you'll notice that in these three if and else statements, we are looking at the value of region code. And based on the value of region code, I wanted to execute two statements. I wanted to create a new variable named region that will assign the value of either Asia, Europe or North America. And I wanted to output to a different data set. You'll notice on the data statement, I actually listed three different data sets. SAS will generate the Asia, Europe and North America datasets, and I can use the output statement to indicate which data set each observation should be written to. If I try and run this program as it is, we are going to have a problem. In the log, we have an error because I can't use a compound expression after the keyword then. Instead, I need to use if then do syntax. So let me come back to the program and modify the syntax. So if region code equal to A, then do. After that statement, I can list as many executable statements as I want. So I'll separate the region equal to Asia. Remember, if I use an if then do statement, I must close that block with an end statement. So SAS knows if the condition is met, then it will execute all the statements that are between do and end statements. So I'll make a similar modification to the other statements as well. If region code equal to E, then do, and region equal to Europe, and output Europe, end. And the final condition will just be else do, semicolon, region equal to North America, output North America, and we will close that block with an end statement as well. Let's run the program. I'll check the log and notice that three different datasets were created: Asia, Europe and North America, each with a different number of observations. And if I examine the output data, I can see we have Asia, Europe and North America. This is if then do syntax. It is an incredibly powerful way to bring conditional processing into your data step. In conclusion, we have discussed set statement, creating new variables with some numeric, character and date functions. As we dive deeper into the programming, we will learn many more functions. Also, we have seen conditional processing with if then else and if then do statements. If you have any questions or doubts, please leave them in the comments below or reach out to me through the mail ID mentioned in the about section of this channel. Thanks for watching and I'll see you in the next video.